All right. Welcome to another Cloud Native development session. And today we're gonna have a look at a end-to-end serverless application called Nodeless. But before that, quick news flash, a couple of things that I found interesting, tooling, and a few articles there. Um, First one here I wanted to point out is a little tool called Sloop. Um, Essentially, think of it as a nice way to visualize Kubernetes events, past events, resource state event changes, really. And yeah, check it out. Looks useful. Another one, if you're into eBPF, and who isn't nowadays, check out this awesome eBPF repo. A lot of useful stuff in there. Can spend hours and hours. Um, the third one I wanted to point out, actually both of them, the permission manager, kind of like the missing bits in Kubernetes. As you might know, Kubernetes doesn't really treat users as first-class citizens, and permission manager here is a really nice way to go about that. Um, Allows you to create, users and yeah, essentially kind of like a missing tool. Related to that, there is Kiosk. Not sure if I pronounced that correctly. That's my pronunciation. I'm not a native speaker. Um, and this is kind of like multi-tenancy extension for Kubernetes. And what that essentially means is that it um, think of it kind of like a namespace operator. So creating a couple of things that you would expect in all these different namespaces, setting certain things like limits, etc. And yeah, I would say you know it's not really like hard multi-tenancy. Can't be with Kubernetes because the control plane is shared in any case. So it's a nice way to set up namespaces in a way so that users in these namespaces are somewhat segregated and don't step on each other's toes. Let's put it that way. A couple of articles I found quite interesting. Rory here has a very nice walkthrough in terms of vulnerability scanning. Stefan Prodon of Weaveworks did a very nice talk on GitOps Toolkit, a new open source project he created. And we're going to have a look at the GitOps Toolkit next time around. But Perkins has a very nice list of service mesh use cases. You can read through that, maybe comment on that. If you're in that evaluation phase, which I know based on the conversations I have, a lot of you out there actually are, you wonder like, what am I going to use that for? And you might have one concrete motivation like progressive deployments and wonder, what else can we use that service mesh for? And last but not least, if you are into writing Kubernetes operators, so custom controllers, but not really a Gopher, so you're not into Go development, um, but more like Shell, very nice tool there called um, Flant, or the shell operator from Flant. And yeah, there's an update on that. Have a look at that. Really, really nice. All right. And before we get into the actual service application, uh, very quick, um, you know, uh, flashback really. When I picked out this T-shirt in the morning, um, I looked at it and like, okay, that's only like what 4 years ago. And looking at the um, wonderful companies that are listed here, not many of them are around anymore, at least not in the current form, right? Many of those have either been acquired or yeah, discontinued their operations. Um, Few of them who are still around, like again, only 4 years ago, Weaveworks and Sysdig. Lotse has recently been renamed to Kubernetes. But many of them who sponsored one of the first, I think it was overall the second KubeCon in London back then, are not around anymore. So that's a kind of a testament to how quickly moving our cloud native ecosystem really is. All right, and with that, we're gonna have a look at and dissect a serverless application called Nodeless. And Nodeless, what Nodeless really does is um, put that together to essentially show off how you can build an application end to end, entirely serverless. And I've cloned it here locally so we can have a look at that, the components here. Um, what it really does, it allows you to capture a text. You can scribble something on a piece of paper, capture that, and then recognize certain commands. I defined a list of command words here, right and left and up and down and whatnot. And then using OPA, the Open Policy Agent, essentially a couple of rules there, it then classifies, or OPA essentially is used to filter the output from recognition, Amazon Recognition, which essentially detects text in pictures and then tells you if it detected some of those things, of those command words. It's pretty straightforward if you look at it. And you know what? Let's actually try it out before we look at the architecture. So, piece of paper, nothing on it. My white balance, by the way. There goes my white balance. I'm gonna put something on that we didn't have so far. Let's see. Analyze, list the nodes. So that pulls the already taken images from S3, and these are the OPA rules, right? That's what I essentially have in there. If something is in the list of these candidates and it has a confidence more than 90, then I have detected it, right? That is what AI is these days, right? Um, right, so we don't have Go there yet. So let's try if we can create a Go. So I'm gonna write Go. And I'm gonna take the app, which really is just, a web page, Nodeless, and hope that I'm using that app from that URL, right? That only works from a mobile device, by the way. So I'm gonna make a picture of, huh, well, that's the demo gods not wanting to play along nicely. I don't think that it captured anything. Nah, not really. Okay. Anyways, let's pretend that worked. And let's focus on the actual architecture here. I need to debug that later on, what happened with the capture. So architecture, as I said, I was trying to do that up here. So something has probably changed in the setup there since the last time I tested it. It's been a couple of months. Um, and that was supposed to take a picture, and through the API gateway, HTTP API gateway, ingesting that through a Lambda function or using a Lambda function written in Go that on the one hand uploads the picture into an S3 bucket, and on the other hand uses the recognition API to essentially ask, hey, did you detect um, anything in there, and takes the raw result from recognition, which is a JSON blob, puts that, shoves that into a DynamoDB table, and that is the input of listings that you see here. And in the listings, essentially, I have a very simple container running EKS on Fargate that takes the input here, and all it really does, it applies the the Riga rules, right? So that is what's running in the container. And let's have a look here. So that's listings. And as I said, I have a deployment running as EKS on Fargate. So serverless, didn't have to, provision anything there. And the only thing I had to make sure in that context, in order for the ALB to work, was to run as root here. That's something that we need to fix absolutely. So I have an ingress there that makes provisions the ALB and gets traffic into the EKS cluster, and the deployment, the pods that are running here. That's this nodeless listings that actually is the container running here, and all that is here really is the Go binary that I have created here, and that's it, right? That's all there is. Creating that Fargate EKS on Fargate cluster with this shell script just creates that using EKSCtl with a Fargate profile, and that takes some 50 minutes, 10-15 minutes in that range. And once that's there, you can also, or as a second step, you have to actually create the ALB here, and that essentially uses the again the EKSCtl tool to create the service account there, and to use Ursa. So Ursa, in case you are not familiar with that, very important feature that we introduced last year. My colleague Mike and myself, we wrote that blog post to introduce it. Essentially allows you to attach the privileges on a pod level. So you can essentially say this pod here it's running is allowed to write into the S3 bucket. So rather than attaching that or assigning that to the entire node and all the pods running there, having the privileges, you can specify that through the pods. The way it works is very, very straightforward. You essentially annotate a service account. I've got that here. And in that service account that you're annotating, whatever you're using there, you could use a job. In our case here, we're using deployment. Whatever pod at the end of the day is using that service account has effectively certain things injected, that you know there's a projected volume that's used and an environment variable, all the necessary information that is then used to effectively do this STS. We got that exactly this one here, right? If you look at that call, the very heart of Ursa of I'm rolled for service account is this web identity call, and that is what's happening. In this case, just demonstrating it how to do it manually, but this is what's happening under the hood essentially once the respective data has been injected into the pod, right? So that's what's happening here. Um, yeah, going back here to the Go application, as I said, that's taking what we earlier on wrote in this capture phase here, what we wrote into the S3 bucket, which is the image, and into DynamoDB, which is the actual result, and applying the Rego rule here, which is, as I said, if it has at least 2 characters, which all of them have, and at least 90% confidence, and I could change that here and redeploy it, and then I could say I require 95%, which means a better handwriting. Um, and it has to be in the command list, right? It has to be in one of those commands. And there are really only these 3 endpoints, and they in the UI correspond to these 3 buttons, right? So list nodes, it's the nodes endpoint. Show rules just dumps out the static rules. In a real world setting, you would not, you know, hard code these Rego rule set into your source code. You would have that, let's say, in a config map, whatever, that could be reloaded, and the pod would just read it in just as a file. And the deck commands is essentially this output here, right? That just lists the commands that were detected already. All right, so that's it. And this was really just a relatively high level overview of this serverless app called Nodeless. And again, all of these components, Lambda, very obviously, EKS and Fargate, very obviously, recognition, DynamoDB, S3, all of that is 100% serverless. So you're never facing any kind of provisioning VMs or whatever, EC2 instances. You don't need to worry about scaling. Everything is scaling here automatically. And you can try it out yourself. You can just grab that repo here, right? And yeah, deploy it yourself and give feedback and let me know what else you would like to see there. Okay, I guess that's pretty much it for now. I'm having a look at Streamlabs. Okay, cool. Yeah, that was it for today. And next time around, we're gonna have a look at the GitOps toolkit. And the GitOps toolkit will hopefully be next week already. And we're just gonna walk through that. I maybe spend a little more time introducing GitOps concepts and then effectively walking you through a simple example. All right. With that, thanks a lot for being around. Leave comments and or send me an email if you want to. And yeah, thanks a lot.